Let A, B, C, and D be real numbers that satisfy the system of equations. Okay, this big, complicated system of equations. There exist relatively prime positive integers m and n such that a squared plus b squared plus c squared plus d squared equals m over n. Find m plus n. Okay. Well, my instinct here is to just, on the one hand, it'd be nice to try to solve for A, B, C, and D. That might be very difficult. The other thing is maybe we just try to manipulate these equations in some way to end up with this sum of squares that we're asked about. I don't know if there's going to be any clever simplifications. There's nothing. I mean, oh, you know what? Not all of the equations involve all the variables. So if I write these down, the first equation involves a and b. The second equation involves only a, b, and c. The third equation does involve all four variables. And I suppose this is all possible combinations of products of these three. And obviously the last one involves all four of these variables. One thing I could do perhaps is take the third equation and divide it by the fourth. Then I will get a lot of things canceling. In fact, what I'll have is I'll have the sum of the reciprocals of these numbers. Let's give that a shot. So I'm taking the third equation, dividing by the fourth, and of course, if I have the product of any three and divide by all four, I'll just be left with the odd one out. So this says that 1 over A plus 1 over B plus 1 over C plus 1 over D is equal to 14 over 30 is 7 over 15. Now, maybe if I multiply this by that, I'll start getting a lot of other cancellations of things. Again, I don't know. I'm just manipulating things here. I don't really have an end, a path in sight that'll take us to the end, but I'm going to multiply these two things together. So let's copy that. Multiply by AB plus BC plus CA. So this is equal to negative 28 over 15. I don't even at the moment see if we might have a cancellation. I'm just going to have to sort of hope that something happens. I mean, I do see I have A plus B in a few places. So there's a B and an A. There's a B and an A. A plus B is negative 3. So let's write this as BC over A plus C plus B squared C plus CA over B plus AB over C, AB over D, BC over D plus CA over D minus 6 is equal to negative 28 over 15. So I've replaced two of those with a negative 3. So I should have 1, 2, 3, 4, 5, 6, 7, 8 terms here. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Have I used all the equations? I've used the third and fourth, one divided by the other. I multiplied by this one, and I substituted with the top one. This also, all of this divided by D. AB plus BC plus CA. AB, BC, CA. So that should be negative 4 over D. So we can do another little substitution here. Minus 4 over D minus 6 is equal to negative 28 over 15. I actually don't really like that I have so many things in a denominator, right? I want to write these four things squared. Well, now, if I multiply again by A, B, C, D, a lot of these things in the denominators will cancel, and I know that A, B, C, D is equal to 30. I'm not sure. I might just give that a shot. I will end up with a lot of squares of things, so maybe this is the way to go for now. I have another potential thought here, is what if I just compute A plus B plus C plus D and square the whole thing? And then maybe I can use these equations to manipulate some things. This doesn't seem like a good way to continue what I've got going on here. I'm gonna try something else. Problem is I don't know what the sum of this stuff at the beginning is equal to anyway. Is it worth trying to solve for these things just using substitution methods? Maybe. What kind of equations would we end up with? I think they might be, there's a chance that they remain quadratic in some variable. Maybe I'll give that a shot too. Okay, so I have D is equal to 30 over ABC. And then the third equation is ABC plus BC BC times 30 over ABC plus CA times 30 over ABC plus 30 times AB over ABC is equal to 14. I also have B is equal to 3 negative 3 plus A. So negative 3 plus A times A minus 3 plus A times C plus AC is equal to negative 4. So I have A in terms of C, or C in terms of A. This, I mean, I don't see this helping in any way. I think we're probably going to be better off taking the 4 equations and manipulating them until we get A squared, the sum of the squares. I wonder, I mean, I really don't want to go and cube any of these, like, you know, the sum of these things cubed is going to be a massive expression. There will be, it'll contain all of the cross product, like the cross product sum, whatever you want to call it. But I don't know. Yeah, I just don't see what manipulations we can do to these equations to end up with the sum of squares. I also don't really see a good way of interpreting what these equations could be. Like if we were in 4-dimensional space and A, B, C, and D were the lengths, the side lengths of, you know, a 4-dimensional rectangular prism, you know, then AB, the product is the volume. The thing we're asked for is the length of the diagonal. But what do these other things represent then? Like, what is a plus b? It doesn't represent anything geometrically. So I don't know. Yeah, I think this is just going to be a long time of me just fumbling around with these equations to try and come up with something. So yeah, I don't really know how to do this one. You can leave down in a comment if you figure out how to do this. Thanks for watching.